In this video, we'll talk about how to compare two data sets. We're using the data from exercise number 21 in section 3.2. The data represents the number of fish caught and released. We want to compare the number of fish caught by two friends, Ethan and Drew, over the course of their 10-day fishing trip. We can start by looking at the typical number of fish caught using first the mean. The mean, of course, is the sum of the data divided by how many data values there are. The mean for Ethan is 10, and the mean for Drew is also 10. This tells us that if Ethan caught the same number of fish every day, it would have been 10, and the same thing for Drew. So the mean is really not going to help us distinguish between the two friends. If we look at the median number of fish, we make an ordered list of the data set for each friend. The number in the middle turns out to be 9, which tells us that on 5 of the days, both Ethan and Drew caught more than 9 fish, and on the other 5 days, or on a different set of 5 days, both Ethan and Drew caught less than 9 fish. Again, just like with the mean, these measures of typical value, or measures of center, don't help us make any distinctions between the two friends and the number of fish they caught. So we'll go a little bit further, and we'll look at the standard deviation, which gives us a measure for how much variation there is in each data set. The standard deviation for Ethan is 4.9. The standard deviation for Drew is 7.9. For instructions on how to calculate the standard deviation, take a look at some of the other videos posted in my math lab. Because the standard deviation for Drew is larger than the standard deviation for Ethan, that tells us that the number of fish varies more when we look at the numbers for Drew. The numbers for Ethan vary less. You can look at the data for Ethan, and with the exception of the 24, you'll see that the number of fish caught on a daily basis is more consistent than it is for the number of fish caught for Drew. There's more variation in the number of fish caught day to day by Drew than there is for Ethan. The standard deviation gives us a nice way to compare the variability in the values of the variable, in this case, number of fish. Another way to get a look at this is to look at what's called the 5-number summary. Remember that the 5-number summary shows us the smallest and largest value, the quartiles, and the median. The 5-number summary for Ethan is 5, 8, 9, 10, 24. The 5-number summary for Drew is 1, 2, 9, 18, and 20. One of the things you want to look at when looking at the 5-number summary is what's called the inner quartile range. The inner quartile range for Ethan is 2. That represents the difference between Q3 and Q1. The inner quartile range for Drew is much larger than that, 16. Again, this is illustrating the difference in the variation in number of fish caught by Drew. One nice way to get a visualization of the distribution using the 5-number summary is using a box plot. To draw the box plot for Ethan, I draw a box from the first quartile to the third quartile. I make a line in the middle of the box at the median, and then I draw a line, sometimes called a whisker, from the bottom of the box or the first quartile down to the minimum value, and another whisker from the top of the box or the third quartile all the way up to the maximum value. The box plots shown here nicely show the inner quartile range, or the middle 50% of days Ethan was catching consistently the same number of fish, as opposed to Drew, 50% of the time, the number of fish he was catching was much more spread out. Of course, Ethan had this one day where he has potentially an outlying number of fish, and those outliers are important to look out for. So on average, the friends caught the same number of fish. The number of fish caught by Ethan was much less variable, but he did have potentially one day that would be considered an outlier. He caught an exceptional number of fish.